Woohoo! It's the last lesson of the week. We will be talking about experimental and theoretical probability today. We are on page 75 in your notebooks. Okay, so experimental versus theoretical. Theoretical is what should happen, experimental is what happens in an experiment. Okay, so the experimental probability is the ratio of the number of times an event occurs to the total number of trials. So a lot more of what we did yesterday, okay? Only now we'll be doing an experiment instead of them actually telling us what happened, okay? So what does happen? That's experimental probability. Theoretical probability is the probability of an event happening based on the possible outcomes. So what should happen? Okay, so we are going to use this spinner below, and I am unprepared and I'm looking for a paper clip. Let's see if Miss Watson can find one. Oh, it's looking unlikely. You know what? We're going to try something else. Sorry, guys. Okay. we're gonna see if this is gonna work. And if not, then we will skip this part of this lesson. Okay, so let's talk about theoretical probability first. So again, theoretical probability is what should happen, okay? So what is the theoretical probability of spinning a section with stripes? Okay, well, I can see I have 4 sections on this side, 4 more on this side, so I know that all of these total number of outcomes is 8. And we're looking for stripes. Well, there's only one box with stripes. So there's a 1 in 8 chance that I'll spin something with stripes. Okay. What is the theoretical probability of spinning a section with stars? Well, there's 2 sections with stars. So I have a 2 in 8 chance. Okay. And when we're looking at experimental versus theoretical, I'm going to simplify it, but I also want to keep this here. That way I can compare that with the experimental probability that I get. Okay. What is the theoretical probability of not spinning a solid or a striped section? Okay. Well, let's see if I can. Okay, solid or stripes. So that means I want stars or dotted, and there's only 3 of those. Okay, so I have a 3 in 8 chance of not spinning a solid or a striped section. Okay, so now I'm going to spin the spinner 10 times to complete. Let's see if I can. My desk is not big enough sometimes. There we go. Okay, so let's spin our spinner. Let's see if this is going to work. Okay. Bet you it's not. Let's just see what we can do. Okay. So we got a dot. So I'm going to make a tally. Okay. We got a stripes. I don't even know what this key goes to. I found it on my husband's desk. Ooh, we just drew all over Miss Watson's notes. Okay, let's try this again. There we go. We have a stars. So that's 3. We have stars again. 4. My fingers keep getting in the way. Let's do that one again. There we go. We got stars. Okay, we've got a solid section. We got stars again. 4, 5, 6, 7, so 3 more times. We got stars. My goodness. We got white. One more time. And we got dots. Let's spin it again because I can hear some of you saying that could be solid too. And we get stars. Okay, so we ran our experiment to make sure I put that back on my husband's desk. Okay, so the total number of spins. Okay, we got 1, 2, 1, and 6. Okay, so now the probabilities. We know it's going to be out of 10. Okay, so stripes. I had a 1 in 10 chance. White, 2 out of 10, which I know is also 1/5. Dots, 1 out of 10. And stars, 6 out of 10, which I could divide by 2 and get 3/5. Okay, so are there any results in which the theoretical and experimental probabilities are the same? Okay, well, we said that we could only get stripes 1 time up here, okay, and I only got stripes 1 time down here, okay, so we got, okay, stripes were the same. If we look at white, we know that wasn't. Dots, okay, they didn't ask us, but if we were to look, dots would only be 1 time. So we got stripes and dots, okay, and then stars happened a lot. And if I were looking at this, I would say that the white section should have happened a lot instead of the stars, and that quite didn't work. So we can see that, you know, experimental versus theoretical, sometimes the probabilities are going to kind of be the same, and sometimes they're not based on your experiment, okay? So we could say stripes and dots were the same for experimental and theoretical. Okay, but we said white and stars weren't. Okay. So now let's flip over to the back. I got this pretty little dot from doing my experiment. Okay. So let's talk about relative frequency. Okay, relative frequency is the total number of successful attempts divided by the total number of trials. Okay, it can be used to make predictions. As the number of trials increases, the relative frequency of an event will approach the theoretical probability. So if I only do an experiment once, it's not very likely to be close to what I say it should happen theoretical. But if I do something 1,000 times versus just that 1 or 2 times, then those probabilities should get really, really close to what it says should happen theoretically. So the spinner at the right is spun 50 times and the results are shown on the table below. Complete the experiment below. Okay, so on a 1, they spun it 12 out of 50 times. Okay, so my relative frequency would be 12 out of 50, which I know I can simplify. And when I do that, I get 6 out of 25. Okay, If I were to spin it 100 times, let's go ahead and finish our table first, okay, for just the 50 times. So I spun a 2 8 out of 50 times, okay? So I could reduce that and say that it's 4 out of 25. I spun a 3 13 out of 50 times. I cannot simplify that. I spun a 4 10 out of 50 times. Well, I know that that is 1/5 if I divide by 10. I spun a 5 7 out of 50 times, which I cannot simplify. Okay. So we are, they want me to spin the spinner 100 times. Okay. We're actually not going to spin the spinner 100 times. We are going to skip that part of it. Okay. We're going to skip that. But I will tell you, if we were to answer this question, said, what did you notice that the spinners, as you spun the spinner 100 times? Okay, I will tell you that the probability when spinning 100 times versus 50 times will be closer to, if not exactly, the theoretical probability. This works just like if you were flipping a coin. If I were to flip a coin 50 times and then I were to flip it 100 times, I would get closer to that 1/2 theoretical probability with my 100 times versus my 50 times. Okay, so now we want to find the theoretical probabilities. Okay, so the theoretical probability that I would spin a 1, okay, if there's 5 sections on the spinner, it would be a 1 in 5 chance for every single number. Okay. So it says, how does the relative frequency change between when the spinner is spun 50 times versus 100 times? Again, this same answer goes here. Okay. Me spinning it 100 times, I'm going to get closer to this 1/5 probability than I am if I only spin it 50. Now we can see that the 4, okay, for the experiment when rolling or spinning the spinner 50 times was exact the same as the theoretical probability. Okay. So it says, suppose the spinner is spun 1,000 times. Predict the relative frequency of each spin. Okay. Again, you can figure this out. Okay. If I spin it 1,000 times, so I had, I'll show you. Okay. So I had a 1 in 5 chance. You can't see this all the way down here. 1 in 5 chance. Okay. Let's figure out the probability of spinning 1. I had a 1 in 5 chance. And I want to know if I do this 1,000 times, right? Okay. Well, 5 times 2 will get me to 10. Add 2 zeros onto that. Well, 1 times 200 is 200. So I would spin a 1 200 times. I would spin a 3 200 times, a 5 200 times, a 2 200 times, a 4 200 times. Okay, so that's the number of times that I would spin it. My frequency, my relative frequency is still going to stay the same. I still have a 1 in 5 chance of spinning these. So no matter how many times I do it, okay, my theoretical probability will never change because 200 over 1,000 still reduces down to my 1/5. So it will not change. No matter how many times I do something, my theoretical probability will never change. Your experimental probability can change, but your theoretical probability, what should happen, will never ever change. Okay. If you have any questions on this, again, I know I keep saying this in every single video. Join me on Zoom. Okay. Tuesdays and Thursdays from 9 to 11. Sound like I'm advertising for something. You can email me. You can message me on Canvas. You can start up a discussion on Canvas. And again, the discussions on Canvas, guys, if you want to talk to each other through Canvas, talk to each other through the discussion. It does not just have to be at school, about school, but it does have to be school appropriate. Okay. Have a great rest of your week and enjoy your weekend.